This is our review for quiz number 9, next to the last quiz, reviewing trig graphs. So, we've been working our way up to graphing, so you should be comfortable at this point graphing any trig function that looks like f of x equal a, either a cosine or a sine, b, and then x minus h plus k, something like that. Okay, so let's look at the first one. The amplitude of the first graph is 3. Okay, the period is going to be 2 pi divided by 1/2, which is 4 pi. The vertical shift, this is shifted 5 units up, so it's a positive shift. The phase shift is minus pi over 2, or if I ask you, that's a pi over 2 shift to the left. The next one, amplitude is pi. Period is 2 pi divided by 5. The vertical shift is down by 1, and the phase shift is a phase shift of pi to the right. Okay, remember that's a positive shift. Okay, let's look at the next one. Now, I don't think there were many in the homework like this, but this is just putting things together. You should be able to recognize, what is this? This is a function that starts at 0, ends at 0, and is 0 halfway in between. So this is based on sine, okay? So I know this is a sine curve, but it doesn't, sine usually goes up to 1 and down to -1, so it's going to be negative. So this is going to be reflected. So I know it's reflected. What is the amplitude? So if I look at this red line that is right here, that is drawn, how far up does it go? It goes up 1, and it goes down 1. So the amplitude is 1. So this is negative sine. And we'll figure out it's starting at 0, and it goes to 2 pi. So that means the period is 2 pi. So remember, sine of x and cosine of x, they both have a period of 2 pi. So there's no number in front of the parentheses here other than 1. And then I look at this, so this is negative sine of x. Okay, and is there a vertical shift? Yes, normally that graph would be here at 0, but it's moved up 2. So this is negative sine x plus 2. Give a trig function that is described below. A reflected sine function with an amplitude of 4. That's what the amplitude of 4, that's the reflection. So negative 4 sine. It has a period of pi over 4. So remember, if the period is 2 pi over b, then b is also 2 pi over the period. And remember, b is that, we're trying to get things of the form f of x equal a sine b x minus h plus k. So in this case, the period is pi over 4, so b is equal to 2 pi divided by pi over 4, which is just 2 pi times 4 over pi, which is 8. So that tells me that this is 4 times the sine of 8 and a phase shift of pi over 6. So a positive phase shift going to the right, pi over 6. That's x minus pi over 6. And then it has a vertical shift of 17. There we go. So double check it. This is an amplitude of 4. It is reflected with a negative sign. The period is pi over 4. That means b is 2 pi divided by pi over 4, which is just 8. That's where I get this 8 from. It's shifted positive pi over 6, so that's x minus pi over 6, vertical shift of 17. Next one, a cosine function with an amplitude of 12. So that's 12 times the cosine. And it has a period of 5 pi. So that means that b is 2 pi divided by the period. So that's 2 pi divided by 5 pi, which is just 2/5. So this is 12 times a cosine of 2/5. A shift of negative pi, so that's shifted to the left. So x plus pi, and then it has a vertical shift of -3. So cosine function, amplitude of 12, period of 5 pi. That means b is 2/5, and then shifted pi to the left. So a negative pi shift, so that's x plus pi, and then vertical shift of -3. Okay? So just, there's a lot of stuff packed in there. You know what each of these pieces is. Just take your time in decoding all of those. Graph the following trig functions over one complete cycle. Now what this one does have, the x's are already labeled for you. Don't count on that. We've talked about in class how to do this where you know to label them yourselves. The amplitude here is 3. The period is 2 pi. There's a vertical shift of 2 up, and this is reflected about the x-axis. So with the vertical shift, I know that's been shifted up 2, so I will have right here at 2. That's where I'll have the line. The amplitude is 3. So this is a reflected sign. So normally the sign starts at 0, ends at 0. Halfway in between is 0. Halfway in between the first 2 points, it normally goes up 1, but I've got a -3, so mine's going to go down 3. 1, 2, 3, right here. And normally halfway between these 2 points is -1, but when I multiply the -3, I get +3, so 1, 2, 3, right here. So if you see what this graph does, it's like this. That is one complete cycle of the graph. It goes up to 5, and it goes down to -1, and I see that it's between 0 and 2 pi. 2 cosine 2x minus 1. Amplitude is 2. Period is 2 pi divided by 2, which is pi. So if I look at 0, count off 4 spaces, 1, 2, 3, 4. That's pi. That's pi over 2. That's pi over 4. So 1/4, 2/4, this is 3/4 pi. And if we look at it, the shift of -1. So if I draw a line at -1 right here, that's where I'm going to do my graph. Now normally the cosine starts at 1, but I multiply by 2, so mine's going to start 2 away from that line, and then it's going to end at the same spot. Normally halfway between the cosine is 1 below. When I multiply that by 2, I'm going to be 2 below the line. And then halfway in between those first 2 points is 0, and the second 2 points is 0. We see a curve that does this and continues on. Okay? And so let's see, vertical shift was 1 down, reflected about the axis was no in this case. Graph the following trig functions over one complete cycle. Okay? So, what is the amplitude of the first one? The amplitude is 2. The period is 2 pi divided by 2, so the period is pi. The vertical shift is 3 upward. The phase shift is pi over 4, and this is a shift to the right. And has it been reflected about the axis? That answer is no. So what I want to do, let's just say, okay, here's 0. Count out 4 spaces, 1, 2, 3, 4. That's pi. That makes this pi over 2, pi over 4, and pi 3/4 pi. And I know that I've got a vertical shift of 3, so I'm going to be graphing at this point right here. And I'm shifting everything to the left, to the right by pi over 4. So when I graph this, instead of starting at 0, I'm going to start graphing this at pi over 4. And instead of ending at pi, so this is 4/4, this is 5/4 pi. So I've shifted everything to the right by 1. And now I graph it just like I normally would any sine function. Sine starts at 0, ends at 0. Halfway in between is 0. Normally the sine curve goes up to 1 between the first 2 points, but I have been multiplied by 2, so I will go up here 2. And then normally between these 2 points it's down by 1, but this is down 2. So you see the sine function right here. So it starts at pi over 4 and ends at 5 pi over 4. And the next one. What is the amplitude of this guy? Amplitude is 2. The period is 2 pi divided by 1/2, which is 4 pi. Vertical shift. There's a vertical shift down of 1. There's a phase shift. So the phase shift is pi or minus pi, but anyway, the point is this one goes to the left. Has it been reflected about the axis? Yes, it has. So to graph all of these, so starting at 0, the period is 4 pi, so 0, 1, 2, 3, 4, this is 4 pi. That means halfway there it's 2 pi, that's pi, and that is 3 pi. My vertical shift here is down 1, so let's draw a line here at down by 1, and I've shifted to the left by pi. So what that means is, here's negative pi, so I'm going to shift this cosine to the left by 1. So instead of going from 0 to 4 pi, I'm going from negative pi to 3 pi. So you see where I need to graph this. And so let's see, what does a cosine function do? So normally a cosine function starts at 1 above the line, but here I'm multiplied by -2, so I'm going to be at 2 below, which is right here. And then normally it ends at 1 above, but multiply that by -2, so I'm going to end at 2 below. Halfway in between, normally I'm 1 below, but when I multiply that by -2, that puts me 2 above, which is what we see there. And then halfway between the first 2 points is a 0, and the second 2 points is a 0. So what we see this curve doing is like this. So that is -2. It's an inverted cosine, 1/2 x plus pi. That means pi shifted to the left and down by 1. And here it asks you some questions. Maximum value, minimum value. You look at this first one, the maximum value of the first curve is right here. That point is pi over 2, 5. So the first one has a maximum at pi over 2, 5. And minimum value. Look at the next curve. Where is its minimum value? That is what? Pi 1, which is this point you see right here. The x is pi, y is 1. So the next one is pi 1. Maximum value of the next curve. The next curve reaches a maximum at pi 1, and it reaches a minimum. There are actually 2 places here. It's negative pi, -3, or 3 pi, -3. Either of those will do for max and min value of the graph. Okay, I believe that's it. That's the review. Okay, so guys, we spend a lot of time on this building up. When we get to that last part about the phase shift, that's sort of the hardest thing that puts several things together. So make sure you've got that understanding down pretty easily. Okay, that's it.